Writing chemical formulas. There are two learning objectives in this video. First, learning objective 1, LO1. Students should be able to write chemical formula of ionic compounds at the end of this lesson, as well as LO2, lesson objective 2. Students should be able to write chemical formula of common covalent compounds. Under ionic compounds, there are two types. The simpler one is type 1, where ionic compounds contain only a metal and a non-metal. And the type 2, which is slightly more complicated, ionic compounds containing polyatomic ions. Poly means many. Polyatomic means more than one atom. For example, SO4 2- ion has more than one type of atom. OH- ion, likewise, is also a polyatomic because it has two different types of atoms inside. So let's do the first type, simple one, between a metal and a non-metal. Now, a metal ion is basically the same as the name itself. For example, sodium is still sodium ion, but a non-metal now ends with IDE. For example, if hydrogen is a negative ion, it's called hydride. Oxygen is oxide. Nitrogen, nitride. Sulfur, sulfide. Fluorine, fluoride. Chlorine, chloride. Bromine, bromide. And iodine, iodide. For example, sodium chloride. Sodium plus chlorine, when they combine together, they form sodium and chloride. Take note that the formula, the name has changed to IDE instead of chlorine, INE. Rule 2. Charged ion depends on its group number. For example, group 1 has a valency of 1. Valency 1 means one of its electrons is involved in a chemical reaction. You either give or take or share one electron during a chemical reaction. So for group 1, they give away. So when you give away one electron, you have a charge of +1. For example, group 1 elements are sodium and potassium. It has a single 1+ charge. Now for group 2, valency is 2. It has 2 extra valence electrons in this outer shell. So you give away 2 electrons to achieve a charge of +2 for the ion. Hence, magnesium ion is 2+, calcium ion is 2+. Likewise, for group 3, which is also a metal, you will give away 3 electrons. So it's Al3+. Now for group 5, group 6, group 7, they are non-metals. And non-metals receive or share electrons. So to form any compound, they receive 3 electrons. Valency 3 means it involves 3 electrons in a chemical reaction. So it takes in 3 electrons, and hence it's a -3. So group 5 element, nitrogen, has a 3-, phosphorus 3-. For group 6, 2 valence electron, it needs to receive 2 extra electrons to become stable, and hence it has a charge of -2, formula written as 2-, O2-, S2-. So this is oxide and this is sulfide. As for group 7, you need 1 more electron to be stable, hence it's taking 1 electron, and hence it has a charge of -1. So all group 7 elements has a single negative charge. Now let's try writing the formula of this ionic compound. Sodium chloride. First you must know that sodium is group 1, so it's Na+. Chloride comes from chlorine. Chlorine is group 7, so chloride is Cl-. When you want to write a chemical formula of ionic compound, you must balance the charge. So the charge of +1 and -1, they are equal and opposite. So together they form NaCl. Next, let's look at calcium oxide. Calcium is group 2, so it's calcium 2+. Oxygen, oxide comes from oxygen, and it's group 6, so it's O2-. And the charge now is equal and opposite. So they simply combine these two together to form CaO, because 1:1 ratio. Okay, iron 2 oxide. Iron is a transition metal. Transition metals, this is the oxidation state or the charge of the ion. So iron 2 means Fe2+. Whenever you see the number inside bracket, it simply means the charge of the ion. So iron 2 and oxide is 2-. Again, equal and opposite, that's easiest. You simply write down the FeO, combine them together 1:1. Now, this is slightly different. Calcium fluoride. Calcium group 2 Ca2 plus. Fluoride comes from fluorine, is group 7 F minus. So fluoride is F minus, and now the number is not the same. It's 2 plus and 1 minus. So what you do is you need one more fluoride to get 2 minus in order to balance with 2 plus. Hence you have 1 calcium combined with 2 fluoride. So it's CaF2. Now you actually also combine them by crossing. For example, Ca2 plus F minus. By crossing the number, removing the sign but cross the number, you will get Ca1, because a single minus will be 1 and F2. So the 1 you don't need to write. Hence it becomes CaF2. So by crossing method or by writing the multiple of the fluoride, you get exactly the same formula, CaF2 and CaF2. Now crossing is easier, okay, but you must understand the reason for crossing is that you need multiple units of this fluoride in order to balance with the calcium, because fluoride has a lesser charge. Okay, let's look at the lead-4 oxide. Lead-4, Pb4 plus, oxide is O2 minus. Now we simply cross the 2 and the 4 to each other, so you have Pb2O4. But after crossing, you must reduce to the simplest form, okay, because you actually need only 2 oxide to balance with 1 lead. So in other words, simplest form is PbO2. Now let's try next one, aluminium. Aluminium is group 3, hence it has a formula of Al3 plus, oxygen, oxide come from oxygen, O2 minus. So by crossing the number, you get Al2O3. This is aluminum oxide. Next we come to the polyatomic ions. It may look a bit more complicated, but it is quite easy. Most importantly, you must memorize the formula of these polyatomic ions. For example, ammonium NH4 plus, hydroxide OH minus, nitrate NO3 minus, sulfate SO42 minus, and carbonate CO3 2 minus. You must remember them. And these are polyatomic because there's more than one element, more than one atoms inside the formula. Okay, let's try sodium hydroxide. So sodium is Na from the periodic table. Hydroxide, remember you must memorize OH minus. So again, you look at this thing. I have 1 minus 1 plus, equal and opposite. You simply combine together NaOH. Very simple. Now calcium, group 2, Ca2 plus. Carbonate, CO3 2 minus. Now when you look at the charges, you don't look at the number at the bottom. CO3, it means that this whole unit of CO3 has a charge of 2 minus. So if you compare calcium and carbonate, 2 plus 2 minus is equal and opposite. Hence, you combine them together to form CaCO3. The charge neutralize each other. Next one, iron. Iron 3, Fe3 plus, and SO4. The SO4 is a sulfate. Together, it has a 2 minus. So you realize that the charge is different. 3 plus for iron, 2 minus for sulfate. Hence, you must cross a number. So you have Fe2 and SO4. Because SO4 is together, so when you multiply by 3, you must put a bracket. It's similar to mathematics. So what I try to say is this. You have 3 units of sulfate in order to combine with 2 units of iron, so that they have equal and opposite charge in total. Now, whenever you put bracket, you make sure there's a number outside the bracket. And make sure there's more than one element inside the bracket. Next, calcium. Ca2 plus, NO3 minus. The charge for nitrate is NO3 whole thing minus the single minus. So a single minus and 2 plus, you cross the number, you form Ca bracket NO3 together, yes, a 2. because the 2 belongs to the entire NO3. This is polyatomic, and this is the correct formula. Next, copper 2 hydroxide. Copper 2 means Cu2 plus, hydroxide is OH minus. Now, a common mistake is they simply cross a number and you form CuOH2. Is this correct? No. Something is missing. When you write CuOH2, it simply means 1 copper, 1 oxygen, and 2 hydrogen. But that's not what you want, because you want 2 units of hydroxide. So you must have O2H2. But of course, you don't write O2H2. You must put a bracket around it. So this is wrong. So what you should do is view OH as a unit. So when the number of 1 might cross over, the number of 2 cross over, you get the formula Cu bracket OH, because OH is always together, and any number multiplied to it must be put outside the bracket, CuOH2. Let's try the next one. Aluminium. Aluminium is Al3 plus, CO3 2 minus. Now take note, the 3 for carbonate has nothing to do with the charge. It simply means that 1 carbon and 3 oxygen together, this polyatomic ion has a charge of 2 minus. So 2 minus and 2 plus, they are not equal and opposite, so you must cross the number. So the 2 goes to aluminium, you have Al2. Do you need to put bracket? No need, because Al is a single element. You don't put the bracket around a single element. You only put a bracket around a polyatomic ion. So carbonate is a polyatomic ion, so you must put a bracket CO3, then close the bracket 3. Where does this 3 come from? It comes from the aluminium, it cross over. So in other words, it means that 2 units of aluminium combined with 3 units of carbonate. So is it true that 2 units of aluminium is like this? Al3 plus, Al3 plus, and 3 units of carbonate is CO3 2 minus, CO3 2 minus, and final CO3 2 minus. You have 3 units of carbonate in order to combine with 2 units of aluminium, so that they have 6 plus and 6 minus, equal and opposite. So the formula for aluminum carbonate is Al2 CO3 3. Now we come to the covalent compounds. The formulas are more straightforward. Covalent compounds are formed between a non-metal and a non-metal. Mono means 1, di means 2, tri means 3, tetra means 4. So oxide, monoxide means 1 oxide, so it's carbon and 1 oxide, carbon monoxide. Oxide, di, so it's carbon and 2 oxide, because di means 2. Sulfur, sulfur and 2 oxide, because di means 2, dioxide. And tri means what? Tri equal to 3, so therefore sulfur and 3 oxide, so sulfur trioxide. Silicon, Si, dioxide means oxygen has 2. Now this is a bit tricky. Tetrachloride, tetra refers to 4 chloride, so you can see carbon and 4 chloride, CCl4. So carbon tetrachloride means 1 carbon and 4 chloride combined together. Now dinitrogen oxide, di means 2, so it's dinitrogen oxide. If it's not specified, it's 1. Now sulfur trioxide, tri means 3. Sulfur trioxide means sulfur and 3 oxygen combined together to form sulfur trioxide. Other covalent molecules of elements are mostly diatomic molecules except noble gas. For example, hydrogen gas must be H2, nitrogen gas N2, oxygen gas O2, ozone, the special one you may want to remember is O3. Ozone is O3. Fluorine gas F2, chlorine gas Cl2, bromine liquid, bromine is a group 7, all are diatomic, Br2, iodine is I2. So you realize all the non-metals actually exist as a pair. Now what is the reason for doing so? Let me give you a simple example of hydrogen. Hydrogen is a single electron And by itself, the first shell, the only shell, you need to have 2 electrons. So hence, you share with another hydrogen. So they have achieved a completely filled shell of 2 electrons in the first shell. So the first hydrogen share 1 with the other friend, the other one share back 1. So each has 2 on its outer shell, which is the only shell. So they become stable.